In the Mdcat series, I am starting with the Chemistry MCQs chapter number 2. In this video, I will explain you some easy as well as difficult MCQs, starting with the easy or simple MCQs of chapter 2, the atomic structure. The E to M ratio of electron is 1.7588 multiplied by 10 raised to power 11 coulomb per kg. Second MCQ is the maximum ratio for positive rays is obtained for hydrogen, helium, neon, boron. So the correct option is option A, hydrogen. Which of the following is false? The first option is electrons travel around the nucleus in a specific permitted circular orbit. Now, this statement is correct according to the Bohr atomic model. The next MCQ is an electron do not lose or gain energy as long as it moves in a specific orbit. Now, this statement is also correct according to the Bohr atomic model. Now, let us go towards the third option. An electron can jump from one energy level to another by absorbing or losing energy. It is jumping from higher to lower, so it is losing energy. It is jumping from lower to higher, so it is absorbing energy. This option is also correct according to the Bohr atomic model. The angular momentum of an electron is not quantized. Now this statement is not correct because the angular momentum of an electron is quantized. So the correct option is option D, which is the false statement. Now the fourth MCQ is cathode rays was given the name electrons by. The correct option is G.J. Stoney. The next MCQ is Bohr's model of atom or Bohr atomic model is contradicted by. The correct option is Heisenberg uncertainty principle. According to the Bohr atomic model, we know that electrons are moving in the fixed circular paths called orbits or energy levels, and they are revolving with a definite velocity around the nucleus. But according to the Heisenberg uncertainty principle, we cannot know position and momentum of electron simultaneously. Means that at a fixed time we cannot know both the position and momentum of the electron. The Bohr atomic model, electrons are revolving in a fixed circular path, so their position was known and their momentum was also known, that they are revolving with a definite velocity. But according to the Heisenberg uncertainty principle, we cannot know the position and momentum of electrons both at a particular time. So, the Bohr atomic model is contradicted by Heisenberg's uncertainty principle. The next MCQ is in discharge tube, gas becomes a conductor at a pressure of. The correct option is 0.1 torr. Remember that millimeter of Hg is equal to torr. In your textbook, there may be written as 0.1 millimeter of Hg. Hg represents mercury. Here the unit used is torr. So the correct option is 0.1 torr. So in discharge tube, gas becomes conductor at a pressure of 0.1 torr. The next MCQ is the splitting of spectral lines in presence of magnetic field is called. The correct option is option A. Remember that the splitting of a spectral line in the presence of electric field is called Stark effect. For which of the following Bohr's theory does not apply? Bohr's theory is applicable to atoms having one electron only. Now let us see the example. See over here, hydrogen is having only one electron. Helium have two electrons, but it has lost its one electron. It is having plus one charge. So now it is having how many electrons? Only one electron. See over here, lithium. Lithium has three electrons. It is having plus two charge, means that it has lost its two electrons. So now it is also having how many electrons? Only one electron. Hydrogen was already having how many electrons? Only one electron. Now it has lost its one electron, so how many electrons it is having? 0. For which of the following Bohr's theory does not apply? So it does not apply to the atoms having 0 electrons or more than 1 electron. So the correct option is option C. Now, which of the following will have same chemical properties? We know that if elements are present in same group, they will have same properties. You will calculate these that which of the following atomic numbers are present in the same groups. I have already uploaded a video for the atomic numbers in groups, that how can you easily calculate it. But now for here the correct option is option A. If you add 19 with 18, you will get the answer 37. Okay, so it means that 19 and 37 atomic number are present in the same group. So the one which are present in the same group will have same properties. So the correct option is option A. The radius of second orbit in hydrogen atom is, we know the formula for radius, that is r is equal to n square into 0.529 angstrom. N is equal to the number of orbit. So we have to find the radius of second orbit. So we will write here 2 whole square into 0.529 angstrom. So it will be equal to 4 multiplied by 0. Which of the following orbital will have maximum energy? In this case, there is no need to see any of these. Just see the number of n. The higher the value of number of n will be, the maximum energy it will have. So here which n is having the highest value? It is n is equal to 5. So it means that this will also have maximum energy, because further the shell is from the nucleus, the more it is having the energy. So n is equal to 5 will have maximum energy. The total charge of 80 electrons is, we know that the charge of electron and proton is same, that is 1.602 multiplied by 10 raised to power minus 19 coulomb. But the only difference that come in the charge of electron and proton is that with the charge of electron there is a negative sign. Okay? Because electrons are negatively charged particles. So the correct option is option C, where we are having minus 1.602 multiplied by 10 raised to power minus 19 coulomb. The energy of an electron in Bohr's atom dash as we move away from the nucleus. Means that as the number of shells will increase and electron will move away from the nucleus, in this case the energy will increase. The energy increases as we move away from the nucleus. So the correct option is option A. The lowest principal quantum number that an electron can have is, we know that principal quantum number represents number of shells, where n is equal to 1, 2, 3 and so on. Here 1 is representing the K shell, 2 is representing the L shell, 3 is representing the M shell and so on. So lowest possible principal quantum number that an electron can have is 1. Remember one point, that n cannot be equal to 0. Now the next MCQ is the orbital with n is equal to 4 and L is equal to 3. For n we know that L is equal to 0 for S subshell. L is equal to 1 for P subshell. L is equal to 2 for D subshell. And L is equal to 3 for F subshell. So now here they say that L is equal to 3. So for L is equal to 3 we are having F. L is equal to 0 is S subshell, 1 is P, 2 is D subshell and 3 is F. So here the correct option is option A, 4F. Now the next MCQ is the node, radial node and angular node of 3s orbital are. So we have to find node, radial node and angular node. The formula for node is n minus 1. The formula for radial node is n minus L minus 1. And for angular node, S is equal to 0, P is equal to 1, D is equal to 2 and F is equal to 3. The same as we wrote for L, right? L is equal to 0 for S, L is equal to 1 for P, L is equal to 2 for D and L is equal to 3 for F. Which orbital is given? 3s. So n is equal to 3. So 3 minus 1, which will be equal to 2. So in option A and B, 2 is given. So the correct option will be option A or option B. Now let us check the radial node. N is 3. L. We are having 3s. So for L, we know that s is equal to 0 in case of L. So 3 minus 0 minus 1 will be equal to. When you will calculate it, you will get an answer 2. Now for angular node, see over here, we are having 3s orbital. So here s will be equal to 0. So when you will put the value 3s, s will be 0. So 3 into 0, it will be 0. So the correct option is option A. Here node is equal to 2, radial node is also equal to 2, and the angular node is equal to 0. How many radial nodes are present in 7s orbital? I already told you the formula for radial nodes. It is n minus L minus 1. So here n is equal to 7. We are having 7s orbital. We know that s is equal to 0 and minus 1. So in this case, how many radial nodes will be present? 6. So the correct option is option A. Now the next MCQ is how many radial nodes are present in 5s orbital. Again we will use the same formula. Here in place of n we will put the value 5. So 5 minus 1 we will get 4. So the correct option is option A. Now the question is how many angular nodes are present in f orbital. For angular nodes, I told you that s is equal to 0, p is equal to 1, d is equal to 2 and f is equal to 3. So there are 3 angular nodes present in the f orbital. The 2 electrons in the first shell will differ in the values of. We know that the 2 electrons should have the opposite spin. So they will differ in the value of spin quantum number. The number of electrons in n shell is. The formula for calculating the number of electrons in the shell is 2n square. For n we know that 1, 2, 3, 4. 1 is for k, L, 3 is for m and 4 is for n. So n is equal to 4. So we will put here n is equal to 4 whole square. So the correct option is option D. 32 electrons will be present in n shell. Now the last MCQ that I am going to discuss with you is the number of orbitals in the n shell. For the number of orbitals we have the formula n square. I already told you that n is at number 4. So 4 whole square will be equal to 16. So the correct option is option A. There will be 16 orbitals present in the n shell. There are many other MCQs that are left and I will discuss them in another video. At the end, don't forget to like, share and subscribe my channel.